Okay, so these are the things that we've already done. When it comes to linear stuff, this is kind of where we got to, right? We know how to plot points, right? We know that the points represent some kind of a relationship between the variables on the axis, right? And sometimes that relationship is called a function, right? We know all about that stuff. We know how to graph a function rule by plotting, make a table of values, plot the points, connect them with a smooth line. And we know what it means to say when a graph looks linear. What is the shape of a linear graph? Straight line, right? It's not really quite correct to say a line because it could be a curved line, but a straight line, that's the best answer to say, right? Linear means the graph looks like a straight line. So the part of it we're getting into now is, well, how do you know when you're looking at an equation that it represents a straight line, right? Linear equations, the x and the y are raised to the first power, like all of these right here, right? The x is, because you don't see an exponent, that means it's raised to the first power, right? So it doesn't have to be in any particular order. I mean, we're going to do slope-intercept today like the second one, but they don't have to be in any particular form to be linear. As long as the x's and the y's are raised to the first power, if you graphed it, it would be a straight line. Now, there's one exception to that, and that would be if you had one term like this that was x times y, like that. Now, in that one, both the x and the y are raised to the first power, but that graph is not linear. So when we say x and y are raised to the first power, it kind of implies that they're in separate terms. They're not in the same term. So we're not interested in that case right there. So anyway, and these are going to be the different kinds of straight lines, the forms of straight lines that we deal with, right? This is, ultimately, we'll know that as the standard form. We'll know that as point-slope form. And this is slope-intercept. Devin, right? Put it away. Okay, but there's two special lines, right? Horizontal and vertical. And what's special about them in terms of what we just said? Because they only have one variable, right? And a horizontal line, again, what did we say about the slope of a horizontal line? It's 0. Now, if I look at this line in particular, what would you say are the coordinates of this point, right? Right here. The x is 0, the y is. Okay, how about this point right here? The x is and the y is. How about this point? The x is 5 and the y is 3. What is the y coordinate of every point on that line? 3. So the equation of a horizontal line is y equals a constant, right? The x is going to be every value along that line, but the y will always be 3. So when you write the equation for a horizontal line, it's y equals a constant. So, and there's the y, it is to the first power, but there is no x, okay? And this, with the same kind of logic, right, if I look at what are the coordinates of this point right there? The x is and the y is 0. How about at this point? The x is 4 and the y is 2. And at this point, the x is 4 and the y is -3. So what's the x coordinate for every point on this line? 4. So it's the equation of the line is x equals 4, right? That equation describes every point on that line, x equals 4, right? So this one is also x to the first. So just got to keep in mind, a horizontal line has a slope of 0, and it has an equation of y equals a number. A vertical line has a slope of undefined. It has an equation of x equals a number. Okay, the slope-intercept form, which you've seen before, is y equals mx plus b. The m is slope. We did that in the last lesson, right? Remember, slope has its own formula. M equals y2 minus y1 over x2 minus x1. And The y-intercept, what does the y-intercept mean? What does that term mean, the y-intercept? Yeah, where does it touch the y, where does it cross the y-axis, right? The y-intercept. So here's examples of slope-intercept form. Right, so y equals 2x plus 3. What is the slope? 2. What is the y-intercept? 3. Okay, what about this one? I don't see the y-intercept. What does that mean that it is? If you don't see a number plus a number out there, then what number is being added? 0. Okay, what is the slope of that line? -5, right? But if there's no number there, that means the y-intercept is 0. That's a particular kind of equation. It's called direct variation because it goes through the origin 0, 0, direct variation. And then y equals -2. Again, what kind of a line is an equation? Y equals -2. We just did it on the last slide. Y equals a number is horizontal, right? Horizontal. And what is the slope of a horizontal line? 0. So when you just see y equals a constant, you could think of it like this. Y equals 0 times x minus 2, right? The slope is 0. That's why you don't see the x, because the slope is 0. 0 times x is 0. And then the y-intercept is -2. And y equals 0, what line is that? It's a horizontal line, but what line on the graph is? It's the x-axis, right? Because everywhere on the x-axis, y is 0, right? If I say, what's the y-coordinate at any one of these points, you would say y equals 0. So that line, oops, wrong way. That line there, that's the x-axis. Okay, so there's going to be 3 kinds of problems in the homework. First is you're given an equation, state the slope and the y-intercept, right? So I'm going to say m equals and b equals. What is the m? No. 5, not ever the x, right? It's just the 5. And what is the y-intercept? -2, right? Easy. How about this one? What is the m is -1/2. What is the slope? Or sorry, the y-intercept? 2/3. Do you think you can handle that kind of problem? Okay, write an equation if you're given slope and y-intercept, right? Y equals mx plus b. All right. How would I write the equation that has a slope of -4/5 and a y-intercept of 7?
Y equals -4/5.
No. X, don't forget the x. Plus 7. Plus 7. Look at that. There we go. How about this one? Three halves x minus 1. Right? And then, so that's the second kind of problem in the homework. And the last is, looking at the graph, come up with the equation. So looking at this graph, you got to identify the m and the b, right? What's the b? What's the y-intercept? Right, that's the b, right? It's wherever it crosses the x-axis. And what is the slope? We did that in the last lesson too. Remember, if it's on a background with the grid lines, try to pick 2 points where it crosses the intersection of grid lines. Like, for example, maybe here and here. Right? What is the change? What is the rise and what is the run? It's 2/1, right? So what is m? M equals 2 over 1, which is 2. Okay, so write the equation of the line. Y equals 2x minus 2. Just like that. So you can spot the y-intercept and calculate a slope. Last one. Last one. I need a slope and a y-intercept. What's the y-intercept? What's the y-intercept? 2, right? That's 2. So that's 2. Okay, what's the m that goes in front of the x? Okay, again, take 2 points where it looks like it's crossing the grid lines. I mean, any 2 points would work. How about if I just pick these 2? Right, what's that? What's the rise and what's the run? What is that there? It's down. It's going down, so it's negative, right? So this is -1 and this is +1. So what does that make the slope? -1, right? So m is -1 over 1, which is -1. Okay, so how do I put that into my equation there? If -1 is the slope, you know, generally you wouldn't even write the 1. You're just going to put a negative like that. So the homework is all problems like that. So you need to take out the book, do it now. I would like to sign off on all of them. And it's not any harder than what we just did there. Let's not have it hanging out there.